110 Algorithms and Programming. So in this video we're going to be looking at hash tables and more specifically the hash function. So let's have a look at the question and see if we can answer it on the next slide. So when h of x equals to mod x 97, so mod being the function and x and 97 being the variables passed to it, is applied as a hash function for a key x, how many keys are in the range of 1 through 1000 have the same hash value as the key of 1094. So here, just as a reminder, mod x, 97 represents the remainder of x divided by 97. And here we've got our four answers, so let's have a look and see which of these is correct. So let's have a look at what this hash function is. It's any function that can be used to map or locate data of a fixed size. Specifically, the hash function is used to map the search key to an index. So I'm just going to go on to another slide to explain this a little further. So let's look at a hash table so we can consider what the hash function is actually giving us. So I'm just going to draw out a little array here, and in practice you would have a much larger array that would extend greatly out beyond here, but just for a visual purpose this would be large enough. So what we've got here is we've got some array with indexes 0, 1, 2, 3. Inside each of these indexes is going to be some sort of data. So let's call this bit of data square. So square is going to have two things. It's going to have a key, and let's call that square. And then it's also going to have a value, and let's just put the value of 4, i.e. the sides that the square has. And so what we're going to do is when we look for the key, so say I use my hash function h of square, this is going to return the index, so 0. So let's go back and see if we can use this analogy to understand the hash function a bit further. So here the values returned by a hash function are called hash values or indexes, as we said on the previous slide. Hash functions can be implemented using the division remainder method, which is explained below. So in this method, the size of the number of items in the table is estimated. So we just estimate how long our table is. That number is then used as a divisor into each original value or key to extract the quotient and a remainder. The remainder is then the hashed value or the index. So what we can see is how this method works down here. So if we have an array of size m, then the hash function of the key is going to just be equal to key mod m. So this will map all the keys into numbers within the interval. So the key we were given in the question is 1094, and the hash value is therefore calculated. This is given by mod of 1094, 97, as we did on the previous slide, and the way we then get the value 27 from this is we do 1094 divided by 97 and calculate the remainder, and this happens to be equal to 27, which is how we get this answer. So in the range of 1 through to 1000, which was also the specified range in the question, the keys where the hash value is equal to h of 1094 are keys where the remainder after division by 97 is 27, as we had with our h of 1094. This is, the values that are applicable are multiples of 97 plus 27, and the value of 27 itself. So for example, 97 times 1 plus 27 will have a hash value that is equal to our h of 1094. 97 times 2 plus 27, and so on, including the value of 27 that we just mentioned at the end. So, to find out the answer for this question, we then have to look and find the number of multiples of 97 that are included in the range of 1 through 1000. So here we do 1000 over 97, which is 10, remainder 30. So the number of multiples of 97 in this range is 10. Since the key is a multiple of 97 plus 27, we use the top value, which is 97 times 10, and add our 27. This gives 997, which is still within our range of 1000. Thus there are 10 values that are a multiple of 97 plus 27 within our range. We then include the 27, the number of keys where the hash value is equal to 1094 is therefore 11. So in this video we found out that the answer is B with 11, and we've managed to look at what a hash table is and specifically what the hash function does.